So this is section 10.5, applications of matrices and determinants. So we've talked about how to do different things with matrices, like inverse matrices and determinants of matrices. So I don't know why I didn't throw inverse in there, because that's going to come up in this section as well. But we need to, what I needed to show you now is how to use some determinants to do something called Cramers rule. So, Cramers rule is made up of two determinants for each variable you're solving for. So, for x, there's a numerator and a denominator. And then for y, there's a numerator and denominator. And if there was a z variable, we'd have a numerator and denominator determinant defined for that as well. It looks like four completely, like we're going to have to do four determinants, but we're actually only going to have to do three. Because the first thing I'm going to point out to you for remembering how to put this information in here is that the denominator is A, B, D, E in both of them. They're both the same. And that happens to be the coefficients of your variables. And that's going to be that way every single time. So I don't memorize the A, B, D, E. I just know that the numbers that are over here, 2, 3, 4, -5, those are going to be in my denominator. So those are both going to be the same. In the numerator, you're going to have this C and this F. Notice for X, C and F are on the left side. Those are the same places the X coefficients were at. So for X, they go on the left side, which is the X column. For the Y, they go on the right side, which is the Y column. So the C and the F, which in this case is 10 and 17, they go for X, they go in the first column. For Y, they go in the second column. If there was a Z, they would go in the third column. All right, so depending on which column out of these two, X is on the left, Y is on the right. So the 10 and 17 is on the left for X, it's on the right for Y. The numbers right above that are going to be the same as the ones in the determinant below it. So I'm missing these two values. They are these same two values that are right below it. So that column down here is going to be the same column up here. This column is missing, so pick the values from this column down here, 2, 4. They're going to go up here on top. So hopefully that makes sense on how I arrange those. Now it's just a matter of doing some determinants. Now, as you do these, my recommendation is always do the denominator first. Because if the denominator turns out to be 0, you can't have 0 in a denominator, then that means you're dealing with either no solution or infinite solutions. And so you want to figure that out right off the bat. So I'm going to start off with these two denominators because they're both going to be the same. So 2 times -5 is -10, minus 4 times 3 is 12. My denominator is a -22. It's going to be the same for both denominators because they are the same determinant. In the numerator of this one, 10 times -5 is -50, minus 17 times 3, that's 51. And so -50 minus 51 is -101. So X turns out to be 101 over 22. Again, I totally made this problem up, so I wasn't looking for anything to have a nice solution to it. And I got that result, not surprised. On this one, 2 times 17 is 34, minus 4 times 10 is 40. So 34 minus 40 is a -6. So Y turns out to be a positive 3/11. So this system has a solution of 101 over 22. I do not think that's reducible at all. And 3/11.